Welcome to ENCOM's Primary Rate ISDN Background and Standards Overview. As one of the two main telephony signaling methods used in the WAN world, Primary Rate ISDN permits fast connect times and flexible use of the barrier channels contained in T1 and E1 lines. Utilizing D-channel signaling, also known as common channel signaling, voice calls are established, taken down, and controlled without using the voice channels themselves. By dedicating channels for call control and faster bit rates, ISDN can make more efficient use of the digital communications infrastructure. Particularly in Europe, ISDN added digital services like caller ID that were previously unavailable, making ISDN very attractive where European standard networks were deployed. In North America, the traditional telephone network already provided such services, which makes ISDN service cost versus alternatives the main market decision criteria there. ISDN, including Primary Rate ISDN, relies on two sets of standards to ensure equipment and country interoperability. One of these sets of standards covers primarily North America, and the other covers Europe and the rest of the world. North American standards are produced by the American Standards Institute, or ANSI. In Europe and the rest of the world are covered by standards produced by the European Telecommunication Standard Institute, or ETSI. We will look at relevant standards from both standards bodies. Operation of ISDN takes place at the three lowest layers of the protocol stack. 1. The physical layer, 2. The data link layer, and 3. The network layer. Each layer provides critical capabilities for Primary Rate ISDN. Layer 1, or the physical layer, establishes transmission for T1 or E1, which defines what each bit and byte means, provides the operations, administration, and maintenance functions to ensure physical layer reliability, and provides Layer 1 alarm information, which is required by Layer 2 ISDN protocols. The primary standards for European Layer 1 cover E1 lines, and they include G.703, G.704, and G.826. For North America, most important standards for PRI ISDN operation are T1.231 and T1.403. Please note that a full implementation of Layer 1 does depend on compliance to additional standards, and let us know if you'd like more information on these. Layer 2, the data link layer, is responsible for guaranteeing packet delivery for Layer 3. Layer 2 establishes and maintains the data link. It packetizes and manages the packet sequence numbering, and it is in charge of packet retransmission as well as verifying end-to-end connectivity with periodic keep-alive messages. The PRI standards that pertain to Layer 2 include CCITT Q.920 and Q.921. There are no significant differences between Euro and North American ISDN at this layer. LAPD, or Link Access Protocol Channel D, is defined by these standards. It works in ABM, or asynchronous balance mode, and that means that all nodes are peers and can initialize, send frames, and handle errors as needed. There is one bit in the HDLC packet that identifies user and network side ISDN. Layer 3, the network layer, is where the ISDN protocol resides. Messages for establishing calls and control are handled here. The network layer finds the network interface and customer interface are different. Switch types define the protocol, and at this layer is managed the state of the call, setup, the conversation, and teardown. Alarms from Layer 2 impact the protocol at Layer 3. It is in Layer 3 that we find we have more complexity in standards. All Layer 3 are derived from standards I.450, Q.930, I.451, Q.931, and ETSI EN 300-403. The two endpoints of a PRI interface are handled differently as the network side and user side, and each have their own sets of protocol requirements. The switch type defines the specific protocol, and they can vary by network and the equipment deployed. The most important standards for Euro ISDN is defined by ETSI EN 300-403. For North America, there are 4 main switch types deployed in the network. They are National ISDN 2, 4ESS, 5ESS, and DMS 100. Additional switch types can be found both in the European world and the North American world, but they are rare. However, with ISDN's ISDN product, it is easy to deploy these switch types or other variants around the world. NCOM allows for runtime selection of the switch type to meet the network requirements, also allowing a single piece of equipment to cover the entire world market. NCOM supplies complete, fully functional PRI ISDN software suites as well as WAN and Ethernet OEM source code to make your project fully standards compliant and successful. Our software has been deployed by the best telecom equipment firms in the world for over a decade. We are here to assist you in whatever you need, and we thank you and look forward to helping you complete your project.